Right, so if you have a read of this question, this is work on proofs. It says n is an integer that is not divisible by 3. So, what can we use to represent an integer not divisible by 3? Well, we can say n equals, choose a letter, perhaps 3n, but I'm going to use the letter k, 3k plus 1, or you could arguably use n equals 3k plus 2. You can see clearly that if k was any number, you can't divide that by 3, or this is not divisible by 3. So prove that n squared, so n squared is going to equal, I'm going to use this 3k plus 1 because it's easier, n squared will equal 3k plus 1 squared, which do remember to write out like this. And that's going to equal 9k squared plus 3k plus 3k plus 1, which equals 9k squared plus 6k plus 1. Now we need to show it's in this form 3p plus 1. So let's just try and factorise 3 out. So that will be 3k squared plus 2k, and we have our plus 1. Now can you see this could be p, so this is in the form 3p plus 1, and p will be an integer. Next one, show that x squared minus 8x plus 17 is greater than 0 for all real values of x. Well, we just complete the square here, so it's x minus 4 squared minus 16 plus 17. So that's going to equal x minus 4 squared plus 1, and this is 0 or greater because you're squaring it, so therefore x minus 4 squared plus 1 is greater than 0 for real values of x. Now if you want to be a bit more professional with this, do write x minus 4 squared, what I highlighted, is always greater than 0. So x minus 4 squared plus 1 is going to be greater or equal to 1, and that just proves it. So for this question here, it says if I add 3 to a number and square the sum, the result is greater than the square of the original number. So when you get these types of questions, it's a state given a reason if the above statement is always true, sometimes true, and never true. So just try some numbers, you'll get a method mark for that. So let's try when x equals minus 5. So we can go, when x equals minus 5, we get minus 5 plus 3 squared equals 4, whilst minus 5 squared equals 25. That's an example of not true, so it can't always be true already from that, but we should know that if we have, you know, x equals 3, let's try 3 plus 3 squared, 6 squared equals 6 equals 36. Where 3 squared equals 9. So this is true in this case. So we know it's not always true, but sometimes true. Hence, sometimes true. By doing those two examples, we've disproved that it's always true or never true. Okay, so this should be a banker. Given that x minus 3 is a factor, find the value of a. So if we know f3 using the factor theorem equals, well, we'll just substitute this in, right? 2 times 3 cubed minus 5 times 3 squared plus ax plus 18. Remember x is 3 here, so that's going to be 3a. And what do we know? If f3 is a factor, that's all going to equal 0. Okay, so 0 is going to equal 54 minus 45 plus 3a plus 18 equals 0. So once we rearrange that, we should get 3a equals minus 27, and so a equals minus 9. And that's our full 2 marks out of 2. That is the easiest way to do that, so I'll recommend doing it that way. Now, given that x minus 5 is a factor, find all the solutions of f of x equals 0. So you need to factorise this 3-term quadratic. So, given that x minus 5 is a factor of f of x, find all the solutions of f of x equals 0. I mean, you could just try to factorise it from this, because we know x minus 5 multiplied by some kind of, we know that's going to be 3x squared. And if you're very good at this, you can jump to that and then factorise this to get the other solutions, or use the quadratic formula to get all of them. But to be safe, you could make a mistake, and it's always good to use a skill. We use our division skills. I hope I've left myself space here. We're factorising this, so we use our algebra skills. So that's going to be 3x squared up here, which is going to give us 3x cubed minus 5 times the 3x squared, so that's minus 15x squared. Right, minus and a minus here, we're going to get 0 there, and that's going to be 10x squared minus 58x plus 40. How are we going to get the 10x squared? So that's plus 10x. Let's multiply that out underneath. That's 10x squared minus 50x. That's going to cancel, so we're going to get minus 8x left plus 40. And then you can see we get the minus 8 here to give us minus 8x plus 40, and that will all cancel to 0. So we know that is another factor, and this is how we got to here. So we've got x minus 5, 3x squared plus 10x minus 8. Now what can we do with this? Can we factorise this. Let's have a look. Over here. Now, depending on how you do this, I can do this by inspection because I know we're going to have a 3 x and x, got to make -8. So we're going to have a -4 and a +2, or +4 and -2, and then I can see +4 here. It's going to give us a +12x, and that -2 is going to give us everything we need. So that's that factorised. So that's equals 0. So x equals 5 is the solution. Don't get sloppy at this. 3x minus 2 equals the solution, so we're going to get 2 over 3. X equals 2 over 3 is the solution, and then you can jump here. X equals -4, and that's your 5 out of 5 marks. Wonderful. Okay, some more proofs questions, because students can find this challenging just to find out what it's asking for. They will apply the skills to answer this. So we need to prove algebraically that n cubed plus 3n minus 1 is odd for all positive integers n. So we can say if n is even, we can write this as as 2m. Now please pause the video and give this a go if you think you can, and check if you're right. So, because 2 times m is always going to give us an even number, right? So this means, so we're going to let 2m equals n. So this means n cubed plus 3n minus 1 is going to equal 2m cubed plus 3 times 2m minus 1, which equals 8m cubed plus 6m minus 1. Now, how could we use this term to prove that it's odd or even? Well, we can factorise the 2 out, because 2 times anything makes an even number. So that's going to be 2, 4m cubed plus 3m minus 1. So we know this term here, 2, 4m cubed plus 3m, is always even. So hence what we have here is, hence this is always odd. Right, so we've done that for even numbers. So if n is odd, we can represent this as 2m plus 1, right? So we've got to do the same as we did before, so it's 2m plus 1 cubed plus 3 times 2m plus 1 minus 1. Let's expand that out. I think I might run out of space. That's going to be 8m cubed plus 12m squared plus 6m plus 1 plus 6m plus 3 minus 1. Now that is going to equal, I'm going to change colour pen so we don't get mixed up with the other question. That's going to equal 8m cubed plus 12m squared plus 12m plus 3. Now you can spot a pattern here. We can factorise 2 out. So that's going to equal 2 4m cubed plus 6m squared plus 6m plus 3. So we just need to state that m squared plus 6m always even. Hence what we've written before, because even add odd makes odd. Three must be always odd, because even add odd equals odd. Hence you prove that it's odd for all positive integers, so you've proven that. Well done. Question 2 is more straightforward. Use a counterexample to show that the following statement is false. A counterexample is that we've got a range here, so we just try a number. So let's just try number 2. So can't use 2 because the range is 3 to 4. So let's just try n equals 3. So we get 3 squared minus 3 minus 1. Well, that's 9 minus 3 minus 1 equals 5. 5 is prime. You'll get a method mark for that. But try a number when trying to get it not prime, and then you might have to try more than once, but that's fine. Remember that will get you a method mark. And then we'll try n equals 7. Let's try n equals 7. So 7 squared minus 7 minus 1 equals 49. Minus 7, 42, 41 equals 41. That's still prime, is prime. Let's try n equals 8. So we're going to get 8 squared minus 8 minus 1 equals 55. We know 55 equals 11 times 5, so not prime, and you're done. Now this question might look a little unfamiliar to you. It says you've got a, b are constants and a plus 4b equals 114. This is given to us, so we've got to use this at one point. It says given also that x plus 1 is a factor of fx, find another equation in a and b and use it to find the values of a and b. So just use the skills we've learnt and see where we get. So what we can know is that when f minus 1, that's going to equal 0. So let's substitute that in. That's going to get us some marks. So that equals minus 1 cubed is still minus 1, so we're going to get minus 24. Minus 1 times minus 1 is 1, so we're going to get a. Minus 3 times minus 1 is plus 3 plus b, and we know that equals 0. Let's just earn some method marks and work our way through this solution. So we're going to get minus 21 plus a plus b equals 0, so we get a plus b equals 21. Wow, we've got two unknowns, so we can't find a or b, but what information have they given us? This, we have to use this. So what skill is this? Let's write this here, 114. Write that underneath and it will look familiar. This is your simultaneous equation skills. So we can minus 1 from 2, do 1 minus 2, and we're going to get left with, cancelling out a's, 3b equals 93. So b equals 31. So once you have b equals 31, we have sub into any equations. Let's sub it into 2. So a plus 31 equals 21. So a equals minus 10. And we've solved this problem. B equals 31. A equals minus 10. So do, with any questions, use what skills you know and see if you can apply all your skills, including GCSE knowledge, and you can answer these questions. This question is not too bad at all, is it? Do pause the video, try all these questions again today or maybe in a few weeks. Make sure you can ace all this, and that will consolidate your proofs and using your algebraic methods. Thank you.